Okay, so welcome back to another video. So in today's video we have the following question: which is bigger, the square root of 2 or the cube root of 3? And this question's special since this was actually an interview question from Cambridge University, from, of course, when you're trying to get accepted into the math program. Now, typically, of course, when you answer this question, no calculators are allowed. So they want you to test your knowledge on how you would actually approach and solve this problem without having to use some sort of technology to help approach this answer. But now in today's video, of course, we're going to show which is bigger out of the two. But before jumping into that, I'm just going to give you the answer right away. The cube root of 3 is bigger. And of course, obviously, you know, if you put these two in the calculator, you get that this is square root of 2 is 1.414. I'm just limiting the decimals. And then over here, cube root of 3 is 1.442. And of course, you would have been done by there, but you know, what's the point of this video if if we don't show any of the work? So I don't need to say any more. All the explanation is basically going to be covered in this video, so let's jump in. Let's actually consider the following function. I'll call this y, so we're going to let y equals x to the power 1 over x. Okay, so if I were to take the natural log of both sides, so we use our rules of natural log, so I would have the natural log of y, and then set that equal to the natural log of x to the power 1 over x. Now, of course, we have the exponent. I could just move that to the front, so that's also equal to ln of x divided by x. And if I were to take the e base to both sides, so it gets rid of the natural log symbol, so we have that e natural log of y and equals e to the natural log of x divided by x. Then we would have that y is equal to e to the natural log of x divided by x. In other words, we set that y was equal to x to the power 1 over x, and then now we just set this equal to e to the natural log of x divided by x. Okay, now that's nice. Now the question you might be thinking to yourself is, what's the next step here? Well, we were to consider some values. Let's say, well, I wouldn't say consider values because the only values you would want to choose is 2 and 3, and then compare which of the two is bigger. So maybe your best approach, for example, let's say, is just to plug in the two numbers 2 and 3 and compare the numbers. But that's not really going to get you anywhere, especially if you're not allowed to use a calculator to directly compute these two values with these two different values. So now the approach we're going to do is that I'm focusing on e to the natural log x divided by x. Well, really, I'll just look at the exponent specifically. So what happens if I were to take the derivative of our exponent, the natural log of x divided by x? Now, of course, doing so, you would have to use quotient rule. So that means this would be g times f prime, then minus minus f times g prime, and then divided by g squared. And if just skipping all that long work, you're going to get that this is 1 minus the natural log of x, and then divided by x squared. Okay, so 1 minus natural log of x squared, 1 minus natural log of x divided by x squared. Okay, so notice that if I were to set the slope equal to 0, for example, because that's where we can decide where it changes slope values from the positives to the negatives. And if I solve that for x, so let's see, equals 0, then of course if we just do some basic algebra, we have 1 minus ln of x, and that's still equal to 0, then set them equal to each other. 1 equals natural log of x. And if you solve for x, you just take the e to both sides. Therefore, you see that x is equal to e. So this is where the slope is equal to 0, and this is where it changes the, this is where the concavity is. It's a concave down. So that means we know that the natural log of x divided by x, it's actually, the function itself is strictly greater than 0. So therefore, we know that natural log of x over x is greater than 0, such that it is increasing between from 0 to e. And as we know that 3 is greater than e, so that would have to mean that if we were to plug 3s for our slope, that means we get a negative value, hence the function is decreasing. So therefore, if I plug 2 and 3, so for the exponent specifically, we see that the natural log of 3 divided by 3 is strictly greater than the natural log of 2 divided by 2. And you can see this if, of course, you can't really see this because you would have to actually put this graph into calculator to actually see the big picture. But you notice that after the function hits e, where the slope is 0, then anything greater than e, the slope actually decreases like slowly, while anything between 0 to e, if you were to plug the input back to the slope, then that means the function actually increases fast. So if you were to plug this back in, you will see that we have that the inequality is that ln of 3 over 3 is strictly greater than ln of 2 over 2. And that means from over here, this is the same thing as if I take the e base, then that would have to imply that 3 to the power 1 over 3 is strictly greater than 2 to the power 1 over 2, which is exactly just rewritten in this form, and we've shown that the cube root of 3 is bigger than the square root of 2. And there's also another way that we can actually show this the easier way. We know that 3 squared is strictly greater than 2 to the power 3, right? So what if I were to say that if I were to, I would actually take the 6th root and then interchange that. So what that means, I'll get that, let's see, if I multiply 3, then square times 1 over 6. And if I say that we do the same thing over here, so it'd be 3 times 1 over 6. Then of course we get that this is 3 to the 1/3, and then this will be written as 2 to the 1/2, which is exactly just the same as we written over here, but this instead we got the easier method, but over here what I just showed from earlier is basically the fun method, basically. So there we have it. We've shown that the cube root of 3 is bigger than the square root of 2, like so. And I'll just box the other one just for the hell of it. All right, yeah, that's pretty cool if you ask me.